So we have the seventh question. How many zeros are there at the end of the following product? 1 into 5 into 10 into 15 into 20 into 25 into 30 into 35 into 40 into 45 into 50 into 55 into 60. The options are A 10, B 12, C 14 or D 15. See here, when you multiply any digit with 10, any number with 10, you get a 0 added to that number. Like for example, you have 13 and you multiply it with 10, you get this 0, 130, this 0, right? So instead of 10, if I multiply 13 by say 100, then I get 1300. I get two zeros here. So they are asking how many zeros are there. So what is 10? How can I express 10 as? 10 can be expressed as 5 into 2. So I will erase this. Okay, right. So 10 is nothing but 5 into 2. So what we need to do is we need to find the combinations of 5 and 2 in this product. Like for example, 5 can be expressed as 5 into 1 and 25 can be expressed as 5 into 5. So wherever we find 5 or 2 as a constant factor in these numbers, we need to bring it out. So let's do it one by one. So the first number is 5. So I'll express 5 as 5 can be expressed as 5 into 1. So I'll bring that 5 over here, 5. Next number is 10. So 10 can be written as 5 into 2. So we have 1 5 and 1 2. I'll bring it out over here into 5 into 2. 15 can be written as 5 into 3. 3 is of no use for us. We need to focus on only 5 and 2. So we have only 1 5 over here, which I will bring it over here into 5. So how can I express 20? 20 can be expressed as 5 into 4, right? 20 is nothing but 5 into 4, which in turn can be expressed as 5 into 2 into 2. So here we have two 2's and one 5, which again I'm going to bring it here into 2 into 2. Next number 25 can be expressed as 5 into 5, which I'm going to bring here again. 30 can be expressed as 5 into 6, which in turn can be expressed as 5 into 2 into 3. So 30 gives me 1 5 and 1 2, which I will express over here. Next number is 35. So let's see how we can write it. 35 can be expressed as 5 into 7. So 35 contributes 1 5 over here, which I bring it here. 40 contributes can be written as 5 into 8, which in turn can be written as 5 into 2 into 2 into 2. So we have 1 5 and 2 3. So I write it as into 5 into 2 into 2 into 2. Next number is 45. 45 can be expressed as 5 into 9. This 9 is of no use. So 45 contributes a 5 over here. And let's see what 50 contributes. So 50 can be written as 5 into 10, which in turn can be written as 5 into 2 into 5. So 50 contributes 1 2 5s and 1 2 to us, which I'll write over here into 5 into 5 into 2. And we have 55 and 60. So 55 can be written as 5 into 11. 55 contributes 1 5. 11 is of no use. And I have 60 left. 60 can be written as 5 into 12, which in turn is nothing but 5 into 2 into 2 into 3. 3 is of no use. So we have 1 5 and 2 2's into 5 into 2 into 2. Now comes the crucial part where I have to count the number of 5's and 2's in this whole thing. Okay, So let me count that manually. 1, 5, second 5, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So I get 5 14 times. 5 appears as a factor in the product 14 times. And 2 appears as a factor in the product how many times? So let's count it manually. It's 1 time, second time, third time, fourth time, fifth time, sixth, seventh, eighth time, 9 and 10. 9 and 10. So 2 appears 10 times. So what we are looking for is a combination of 5 and 2. And 5 and 2 will appear the least times of 14 and 10. That is 5 and 2 will appear as a product, as a factor together 10 times. So 10 will be the answer, which is given in option A. We have the 8th question here. Let x, y, z be a 3-digit number where x plus y plus z is not a multiple of 3. Then xyz plus yzx plus zxy is not divisible by option A 3, option B 9, option C 37, or option D x plus y plus z. So when we say a 3-digit number x, y, z, what we are actually saying is 100x plus 10y plus z. So say a number called 567. It is actually 100 into 5 plus 10 into 6 plus 7, just like how I represented here. So when I say xyz plus yzx, xyz plus yzx plus zxy, this is nothing but 100x plus 10y plus z plus 100y plus 10z plus x plus 100z plus 10x plus y, which in turn is nothing but 100 into x plus y plus z plus 10 into x plus y plus z, that is these things, plus still more to the right, plus x plus y plus z, which are these things. Okay, so which in turn will be equivalent to 100 plus 10 plus 1 into x plus y plus z, which in turn is 111 into x plus y plus z. So let's see with what can we divide this product that we got, this sum that we have got. So in the options we have this option D, x plus y plus z. This is not the right option because they are asking it is not divisible by what? xyz plus yzx plus zxy is not divisible by. It is easily divisible by x plus y plus z. We came to know that it is equivalent to 111 into x plus y plus z, which is easily divisible by x plus y plus z. The second option is 37. Okay, so let's see whether this thing 111 into x plus y plus z is divisible by 37. 37 into 3 is nothing but 111. Okay, so x plus y plus z is also divisible by 37. So both are not the right answer. C and D are not the right answers. So let's go with 9. Let's see whether 111 into x plus y plus z is divisible by 9. Okay, so I'll just write 9 over here. 9 goes within 11 one time, and we have a remainder of 2. With 21, 9 doesn't give a perfect quotient. It gives a remainder of 3. It will be 12 and 3. 12 3 by 9. Okay, so 111 is not fully divisible by 9. Okay, so we have the next option. The next option is 3. Option A, 3. So just let's confirm. 111 by 3 will give us 3 goes in 11 3 times. 2 is the remainder. So 21 by 3 is 7. So 37 it will be the question. So 111 is fully divisible by 3. So what is it which is not divisible? xyz plus yzx plus zxy is equal to 111 into x plus y plus z. It is not divisible by 9. So option B, 9 is the right answer. Okay, so we have the ninth question here. Let P, Q, R and S be natural numbers such that P minus 2016 is equal to Q plus 2017, which is equivalent to R minus 2018, which is equal to S plus 2019. So which one of the following is the largest natural number, whether it's P, Q, R or S? So let's pair these syllables with each other, that is P, Q, Q, R and R, S. So firstly I'll write something like P minus 2016 is equal to Q plus 2017. So that would mean P minus Q is equal to 4033, which shows that P is greater than Q by a value of 4033. So Q is not the answer because there is something which is already greater than Q. Let's go to the second one. The second one, first I'll erase this. Okay, so the second one is Q plus 2017 is equal to R minus 2018. Or I will write somewhere to the side that P minus Q is, because we may need it later on, is equal to 4033. So now I have got Q minus R is equal to minus 4035, which is nothing but R minus Q is equal to 4035. So R is greater than Q by 4035, and I will write it over here. What does this show? This shows us that R is greater than P by 2, right? See, if you do like this, R minus P, then this will cancel out, and 4035 minus 4033, it shows us that R is greater than P. So the only thing left out now is S. We have to compare R with S. So P is not the option because P is lesser than R, and we have to find the largest natural number. So let's go to the next equation which we can draw. In the next equation, we have something like R minus 2018 is equal to S plus 2019. So now if I have an R minus S, then that will be equivalent to 4037. So R is greater than S as well. That is why R minus S will give you a positive number. So this C is the right answer. So R is the largest natural number which they are looking for. Let's try to solve this question in a very quick manner. Just by looking at this equation, P minus 2016 is equal to blah 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 till S plus 2019, that P is larger than Q. Okay, because when a larger number minus a number like 2016, and a larger number like P minus 2016 is equal to a smaller number plus 2017. It's like, say, 2050 minus 50 is equal to 50 plus 2050. Here Q is this 50 and P is something like this. Okay, so just by looking at the equation, we come to know that P is the larger one here. And similarly, in among R and S, we come to know that R is the larger one. So now we have to compare between P and R. Okay, then we would know that P minus 2016 will be equivalent to R minus 2018, and hence P minus R will be equivalent to minus 2. So R minus P will be equivalent to 2, and R is the larger number. So in real examination hall, you should be able to work that fast. That would come by practice. Let's go to the next question. So let's go to the 10th question. How many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4 and 5 without repetition of digits? How many 5-digit prime numbers can be obtained without repetition? So it can be something like 5, 4, 3, 2, 1 or 1, 3, 4, 2, 1, etc. etc. This question is actually a very peculiar question because you can't solve it with a logical approach like how we did in the previous questions or in the future questions. Here you need to know certain things for granted, like you need to know certain rules, and one such rule is that if any number has to be divisible by 3, say the number is xyz, then the sum of the digits of that number, that is x plus y plus z, should also be divisible by 3. So however you arrange these 5 digits, the sum of the digits has to be same. So instead of xyz, if I have something like zyx, then the sum of x plus y plus z is equal to z plus y plus x, right? So it doesn't depend on the way you order these 5 digits, the way you pattern these 5 digits. It's independent of that. So this, if you look at the sum of the digits here, 5 plus 4 plus 3 plus 2 plus 1, then that is equivalent to 15. So as I told you earlier, if the sum of digits of a number is divisible by 3, which is in this case, so 15 here is divisible by 3, then that number is also divisible by 3 and would not be a prime number, because the condition for any number to be a prime number is that it should not be divisible by any number except itself and 1. So however I pattern 1, 5, 4, 2, 3, say I pattern it this way, whatever I do, the sum of the digits are going to be 15, which in turn is divisible by 3, which indicates to us that this entire number 34,125 is divisible by 3. So since in every order of these digits will give us a number which is divisible by 3, the answer would be option A, 0. This is a very peculiar question, and most of the questions would require a logical approach, which is not in this case. In this sum, cross plus 1 cross plus 5 cross plus cross cross plus cross 1 is equal to 1 cross cross. For which digit does the symbol cross stand? For simplicity, I have written cross as x. X plus 1x plus 5x plus xx plus x1 is equal to 1xx. So if we see this number x, this digit x, it appears in the units place. Okay, it appears in the units place of the number 1xx, units place, tens place and hundreds place. So this x is also equivalent to the sum of the units place of the constituent numbers, that is these numbers. These are the units place of the constituent numbers. So for example, say a number 43 plus 34. 3 and 4 are in the units place and its sum would be 77. So the units place of the sum, that is 7, is equivalent to the sum of the units place of the constituent numbers. So here the x which we find in the sum, that is this x, will be equivalent to sum of the constituent x. So let's see how many x are there. X plus x plus x, x plus x plus x plus x plus 1, that is 4x plus 1. So when we add these numbers together, add the constituents together, we get this 4x plus 1. So the units place of this particular number would be equivalent to x. So let's try it out with the options. So the first option is 2. So let's see whether 2 is equal to 4 into 2 plus 1. Whether the units place of 4 into 2 plus 1 will be equivalent to 2. So let's try it out. 2 is equal to 4 into 2 plus 1. No, it doesn't hold good. Is equal to 8 plus 1 will be equivalent to 9. 2 is not equivalent to 9. So option A is the wrong answer. The next option is option 3. So let's try with that. Option 3 equivalent to 4 into 3 plus 1. Units place of 4 into 3 plus 1. That is equal to 12 plus 1 is equal to 13. Yes, this holds good. The units place of 13 is equivalent to 3, which is the option B. So option B is the right answer. So let's go to option B. Yes, option B is the right answer. Okay, we have this 12th question, which is an interesting question. If you have two straight sticks of length 7.5 feet and 3.25 feet, what is the minimum length that you can measure? The options are A 0.05 foot, B 0.25 foot, C 1 foot, and D 3.25 feet. Here they have not told us whether we can break the stick or not. So let's assume that we cannot break the stick, because if we can break the stick, we can measure the most minimum of the lengths. So what we can do is that, supposingly we have a stick, the largest stick, so it is 7.5 feet in length. Then we have a smaller stick, we keep it side by side besides each other, and you have this length of 3.25 feet. We are not breaking these sticks, we just make a mark here, okay, and next time we take this stick off. I'll erase it after making the mark, and we'll place the stick again on top of the mark, and this length would again be 3.25. So the total length from the bottom of the larger stick, of the longer stick, to this particular point over here would be 6.5 feet. So if we deduct 6.5 from this top 7.5, then this would be 1 feet. This distance would be 1 feet. So 1 feet is the minimum length that you can measure, which is given in option C. So let's go to the next question. The 13th question says, a simple mathematical operation in each number of the sequence 14, 18, 20, 24, 30 and 32 results in a sequence with respect to prime numbers. Which one of the following number is the next number in the sequence? See, they are asking which is the next number in the sequence. But before that, we need to know what is the formula that they apply on this sequence, so that this sequence turns out to be a sequence of prime numbers. So we know that 14, 18, 24, 30, 32 are not prime numbers. 14, 18, 20, 24, 24 and 30 and 32. The simple observation tells us that all these numbers are multiples of 2. So let's see what simple operation can we do on these numbers. We can't add these numbers by 2 or subtract these numbers by 2, because then the resultant would still be a multiple of 2, and any multiple of 2 is not a prime number. So to avoid any number from being a multiple of 2, how would you do that? You either add it by 1 or deduct it by 1, or any of the odd integers like plus 3 or minus 3 or something like that. So these are just the first few numbers, like 1 to 32 are the first few numbers that we get in the number sequence, right? So what I would do is, first I delete these things. Okay, so I will try to add these numbers by 1, and let's see why it wouldn't work. 14 plus 1 would be 15. 15 would still be a prime number. So this adding by 1 wouldn't work. 24 plus 1 would be 25. So this adding by 1 wouldn't work. It wouldn't turn out this sequence into a prime sequence. So let's subtract these numbers by 1. Okay. So I'll undo this, and we'll have like 14 minus 1 will be 13. Similarly, 18 minus 1 would be 17. 20 minus 1 would be 19. 24 minus 1 would be 23. 30 minus 1, 29, and 32 minus 1 would be 31. And all these numbers are prime numbers. So we know that the operation that has to be performed here is subtracting these numbers by minus 1. So let's see which is the next. If you see all these numbers, they are in sequence. Okay, after 13 the next prime number is 17. After 17 the next prime number is 19, then 23. They have skipped 21 because 21 is not a prime number. Okay, so next prime number is 23. Then the next prime number 29. After 29, 31 is the next prime number. 33 is not a prime number, not prime. So the next prime number would be 37, because 35 is also not a prime number. So 37 is the next prime number. So this 37 results from subtracting a number in the original sequence. Okay, so x minus 1 would be 37. So here we have seen that the original sequence is subtracted by 1 to get these prime numbers. 37 happens to be over here. When you minus 1, this is something, we call it x minus 1, we get 37. The question here asks us what x is. Which one of the following number is the next number in the sequence, that is the original sequence, and that should be 38, because 38 minus 1 would then give you 37. So 38 is in the option C. So option C becomes the right answer. Guys, the 14th question says one page is torn from a booklet whose pages are numbered in the usual manner, starting from the first page as 1. The sum of the numbers on the remaining pages is 195. The torn page contains which of the following numbers? Option A 5 and 6, option B 7 and 8, option C 9 and 10, or option D 11 and 12. So what happens is, a book is numbered like this. The first page is say 1 and 2, second page would be 3 and 4, then 5 and 6, 7 and 8, and so on and so forth, and maybe n and n plus 1. Sorry, it should be n and n minus 1, okay? Or rather it would be better to say n minus 1 comma n. Okay, so whatever it is, I'll erase this. So one of the pages is torn and the sum of the rest of the pages happens to be 195. So we don't know what is our answer yet. So 195 plus x plus 1, if you like to call it, if you like to put it in an equation, it would be something like this. 195 plus x plus 1 is equal to n into n plus 1 by 2. From where did I get this n into n plus 1 by 2? The sum of first n natural numbers would be equivalent to n into n plus 1 by 2, okay? Sum of first n natural numbers. Natural number starts from 1. So let's assume that the last page is n. Okay. The last page is n. So we will add all these options and check whether it matches our equation. Okay. So the first option is 5 and 6. Page number 5 and page number 6. So 5 plus 6 plus the sum of other pages, that is 195, will be equivalent to 2 not 6. So all we have to see is that whether this number 206 fits into the pattern, whether 206 is equal to n into n plus 1 by 2. If we bring 2 to the other side, then we would have something like 412 is equal to n into n plus 1. Okay, so if we try the same thing for the other options, this is for option A, then we would have varied numbers, varied equations. Okay, let's have n into n plus 1 everywhere. This is common. It's equal to n into n plus 1. And for the option D, again I write n into n plus 1. Okay, for B, we'll just see what this answer is for B. I'm just working out manually. If you can do it mentally, it's far better. 195 plus 7 plus 8 is equal to n into n plus 1 by 2. So this is 210. Okay, is equal to n into n plus 1 by 2. That means n into n plus 1 will be equivalent to 420 is equal to n into n plus 1 for option B. Okay, so let's go to the top and enter this value. 420, whether 420 fits this pattern is equal to n into n plus 1. Okay, so let's go down and let's check with option C. With option C, this would be, I'll erase this. Instead of 7 and 8, it would be 9 and 10. So I just write plus 9 plus 10, and then I would get, instead of 210, I would get 195 plus 19, it's 214. And here I would have 428. Okay, which I would enter over here. Option C, 428. Yeah, for D we have to find out. So D, the option is 195 plus 11, 12 plus 11 plus 12 will give us 195 plus 23, 218, right? And if we come down a bit, we would have it as 436. So I'll just enter it. Okay, so we have to see which of these numbers, whether it is 412 or 420 or 428 or 436, which fits into the pattern n into n plus 1. We know that 400, the square root of 400 is 20, right? So if you have 20 into 20, then that would be equivalent to 400. But here we are multiplying n into n plus 1. N into n plus 1 is like 10 into 11 or 12 into 13 or 14 into 15, something like that. So for 20, it would be something like 20 into 21 or 19 into 20, somewhere close to that, need not be the same, or 21 into 22, something like that. So let's check whether 20 into 21 holds good somewhere, anywhere. Okay, so 20 into 21 will actually be 420. So we have this option 420 here for option B. So option B is the right answer. 7 and 8. This is the right answer. 195 plus 7 and 8. Let's go to the 15th question. Consider the following arrangement that has some missing letters: AB, AB, underscore B, underscore B, C, B, underscore D, C, D, C, D, E, underscore D. The missing letters which complete the arrangement are option A, B, C, D. You can see for yourself. See, we have to, in these kind of questions, we always have to identify a pattern. So what is the pattern that we can see here? I'll rewrite this pattern. Sorry about my handwriting. Pretty pathetic, I would say. AB underscore B underscore, I should have planned the width, underscore, anyways, DCD, so on, DCD, CD, ED underscore D. Here the pattern which I can see from just having an oversight is there is something like AB going on. And if I put a A here, who is going to lose? I'm going to have a AB pattern here. So I'm just going to put it over there, okay? And I can also see that there is some CD thing going on here. Here CD, again CD. There is some repetitive element. If I put a C over here, then this would be confirmed. CD. So there are two patterns that I have observed. Okay, AB and CD. And this missing number is the first missing number, this one, where I got A. In the third missing place I got C. So let's see, here I am having A, and in the third place I am having C. So I will test this option out, test option C out. Okay, I'll just put here A, C. I have already put here, there is a missing one over here, and according to option C it is C. Now there is pretty much more confirmation because I get a BC pattern here, BC and BC. Okay, so option C is the right answer, we already confirmed. But again, if I put this E over here, then I would get D pattern continuing, goes on and so forth. Okay, so let's go to the 16th question.